Good morning, students. Today we will do the second law of Kirchoffs. Kirchoff's second law. Another name of the Kirchoff's second law is Kirchoff's voltage law. Short form is what? KVL. What Kirchoff's voltage law states? It states that in a closed loop of electrical network, in a closed loop of a electrical network, the algebraic sum of potential difference for all components, let us consider a component R. The algebraic sum of potential difference of all components plus algebraic sum of all EMF. What is the EMF over here? Let us consider EMF over here is what? E plus minus. Every EMF has a small internal resistance. So what Kirchoff's second law or Kirchoff voltage law states? In a closed loop of an electrical network, the algebraic sum of potential difference for all components. What are the components here? R and R, capital R and small r, plus algebraic sum of all EMF is always 0. Mathematically it is represented as like this. Algebraic sum of potential difference of all components is represented by R into R, and algebraic sum of all EMF, the summation of all EMF is always equal to 0. Students, using this law we are going to derive the one derivation for current flowing through the electrical circuit. Let us consider the current flowing through the electrical circuit is what? I. Here current I is flowing in all branches of electrical circuit. But before derivation of current I, let me introduce some sign convention where I am going to use in Kirchoff's voltage law direction of electrical current. Let us consider, let me explain the sign convention. Students, here we are going to consider two things. First is what? Direction of tracing is that of flow of conventional current. What is the meaning of direction of tracing? Suppose if I consider loop A, B, C, D, if I move along the electrical circuit in a direction A, B, C, D, so this is my direction of tracing. A, B, C, D. You can go anti-clockwise also, but now I am going to consider only clockwise. So my direction of tracing is what? A, B, C, D. If direction of tracing is same as the direction of the current flowing through the electrical circuit, or maybe opposite, so here I can put two conditions. If the direction of tracing is dot as that of flow of conventional current, if it is same, students remember this, if it is same, then potential difference across R is always negative. I will explain when I apply this condition in the electrical circuit, but now you only remember the direction of tracing is same as that of flow of conventional current, then potential difference across R is negative. If direction of the tracing is opposite as that of flow of conventional current, then potential difference across R is always positive. Student, one more sign convention is left, that is what? EMF. Again I am going to consider direction of the tracing is same as that of flow of conventional current, then EMF is taken as a positive. Remember students, you have to take EMF as a positive. and if it is opposite that of tracing, then we have to take EMF is what? Negative. Students, maybe you are confused still. Now, let us clear the idea using what? Electrical circuit. So now I am going to consider a loop A, B, C, D. The students, here I consider a loop, closed loop A, B, C, D. Again I will say A. So it's a close A, B, C, D, A. My direction of tracing is what? Clockwise. Now I am going to apply KVL. I will apply KVL using sign convention. So now students, from A to B there is no component. Neglect. Now from B to C, one component we got, that is what? R. What is the current flowing through that resistor R? Is what? I. The potential difference across R is what? According to Ohm law, potential difference across R is what? I into R. So here I am going to apply the KVL, I into R, because Kirchoff's second law states that algebraic sum of all potential difference of all components. The first component we come across is what? R. So what is the potential difference here? I into R. Now I have to consider what? Sign. I have to put the sign. My direction of tracing is from B to C. What direction of flow of current? From B to C. So my direction of tracing and the direction of current is same. Then potential difference is what? Negative. So what is the sign of this IR? Negative. Students, we will move further. From C to D there is no component. Neglect. From D to A, first component we come across is what? Small r. What is the current flowing through this small r? Is what? I. So what is potential difference across R? I into R according to Ohm law. So here I will say I into small r. My direction of tracing is from D to A. Direction of current is what? D to A. So it is same. That's why multiplication is what? Negative. If I move further, one more component I got, and that is EMF. That is what? EMF. That is not a component, that is a cell, EMF. So algebraic sum of all EMF, only one EMF is there. So I am going to consider that EMF of a cell. Now my direction of tracing is what? From D to A. What direction of potential difference and direction of EMF? Direction of EMF is always from negative to positive. Remember this, student. This is always direction of the what? EMF is what? Always from negative to positive. So my direction of tracing and direction of EMF both are same. So if EMF, for EMF, direction of tracing and direction of flow of current is same, then EMF is going to be taken as what? Positive. Here I am going to take E as plus. Again we reach to the point A. मतलब we apply the KVL for the whole loop A, B, C, D, A. Loop is completed. KVL is also completed. KVL states that algebraic sum of all potential difference of all components and algebraic sum of all EMF in a closed loop is always 0. We apply KVL. Now, simple mathematics we are going to follow. I will keep E in the left hand side. Minus IR will go there, become plus IR plus I small. Or you can take common from right hand side, student? I. If I take I common, remaining terms are what? R plus small r. So what is the derivation for current, student? I equals to E upon R plus small r. The student, using KVL, we derive the derivation for current I. How to write the answer in the exam, that I will show you. So first you write down the statement. What is the question, student? State and explain Kirchoff's voltage law. You write down the statement. Again I am going to repeat the statement. In a closed loop of an electrical circuit, the algebraic sum of potential difference for all components plus the algebraic sum of all EMF is always equal to 0. This is mathematical expression, this circuit diagram, then write down sign convention, then apply the what? KVL according to sign convention, and this is derivation for R. Students, now let us solve one numerical. Numerical, let me read the numerical. A battery of EMF 6 volt. So student, battery of EMF 6 volt. So this is battery plus minus 6 volt. And internal resistance. Every battery has small internal resistance. What is the value of internal resistance, student? 2 ohm. Is connected in parallel with the another battery of EMF 5 volt. So plus minus 5 volt. And internal resistance is what? 2 ohm. The combination of both the parallel branches is connected to the what? External resistance of 8 ohm. And question is what? What is the current flowing through the 8 ohm? Students, let us consider current flowing through first branch is what? I1. Let us consider current flowing through the second branch is what? I2. And the current flowing through the external branch is the sum of I1 plus I2. Because we observe that for this junction, sum of incoming current is equals to outgoing current. So outgoing current is what? Sum of incoming current. That is what? I1 plus I2. Now we have given the name to the loop. We observe the two loops, 1, 2, and there is a one more loop, the bigger loop. You can apply KVL on either two loops. So let us consider first loop, A, B, C, D. Student, I consider loop name A, B, C, D, A. Apply KVL. If I apply KVL, students, my tracing in the direction of A, B, C, D. When I move from A to B, what is the first component I got? That is what? EMF. I am moving from A to B. Direction of EMF is always minus to plus. So my direction is from A to B. Direction of EMF is opposite. The direction of EMF and my direction is what? Opposite. So student, if EMF and my direction is opposite, so EMF is taken as what? Negative. So here 6 I'm going to take as what? I'm going to take as what? Negative. Then second component I got is what? 2 ohm. What is the current flowing through the 2 ohm? I1. So my direction and the current direction is opposite. Then potential difference opposite hai, then the multiplication of current and the resistance is always positive. So what is the current flowing through the branch AB? I1. Resistor is 2. 2 into what? I1. Direction is opposite, that's why plus. Then move further, B to C, there is no component. Then from C to D, one more component I got, that is what? 2 ohm. What is the current flowing through the 2 ohm? I2. My direction is like this, current direction is same. My direction and current direction is same, then I2 and 2, I'm going to multiply, but it is what? Negative. Move further, I will get another component, that is what? 5 volt. Direction of 5 volt is always negative to positive. My direction and the voltage direction is same, then consider phi as what? Plus. Then it is equals to what? 0, because loop is what? Complete. Apply simple mathematics. So now simple equation I will get 2i1 minus 2i2 minus 6 plus 5 is minus 1. Minus 1 will go there, equals to plus 1. This is say equation number 1. Similarly, I will apply KVL for the loop D, C, E, F. To consider the loop D, C, E, F, D. Apply KVL. If I apply KVL, student, D to C, my tracing direction is what? From D to C, voltage direction is opposite, so EMF is what? Negative. Second component I will get, that is what, 2 ohm. Direction of current is what? Opposite to that my direction. That's why I'm going to take what? It is positive. Opposite means positive. So 2 into what? I2. Moving further, C to E, there is no component. E to F, there is another component we got, that is 8 ohm. And we observe that current flowing through the 8 ohm and my tracing direction is what? Opposite. So I'm going to take what? Plus 8 times of current flowing through the 8 ohm. What is the current flowing through the 8 ohm? I1 plus I2. Moving further, again I reach to the point D. There is no component in between. Loop is completed. The answer is what? 0. Now I'm going to simplify. 2I2, 8I1. So after simplifying, I will get the equation 8I1 plus 8I2 plus 2I2 is what? 10I2 equals to what? 5. Say this is equation number 2. Solving two equations 1 and 2 simultaneously. So for that I will multiply equation 1 by 5. So I will get 5 to the 10I1, 5 to the 10I2, 5 ones are 5. I will take second, this is say equation number 3. I will take second equation below the equation number 3, that is 8I1 plus 10I2 equals to 5. Adding equation 2 and 3. Adding equations 2 and 3, minus 10I2 plus 10I2 will get cancelled. 10 plus 8 is 18I1. 5 plus 5 is 10. So what is I1? 10 upon 18 ampere. I will put the value of I1, that is 10 by 18, in equation number 1. To put I1 equals to 10 upon 18 ampere in equation 1. So 2I1 minus 2I2 equals to 1. If I put value of 10 by 18, so 2 10 by 18 minus 1 equals to what? 2I2. If I simplify further, 2 ones are 2, 2 nines are 18, 9 ones are 9, 10 minus 9, 1, 1 by 9. And if I shift 2, so what is the value of I2? 1 by 18 ampere. So what is my question? Current flowing through 8 ohm is I1 plus I2 equals to, what is I1? The value of I1 is what? 10 by 18. Value of I2 is what? 1 by 18. Denominator is same. So 11 by 18 is the answer. Current flowing through the external resistance 8 ohm. Students, one activity you have to solve. Note down the activity. Two cells of EMF 1.5 volt and 2 volt and internal resistance 1 ohm and 2 ohm respectively are connected in parallel so as to send the current in the same direction through an external resistance of 5 ohm. Calculate the current through each branch of the circuit. Also find the potential difference across 5 ohm resistance. Thank you very much.